So now we have the question regarding gravitational force or gravitational acceleration. So what is asked here? Assuming that the earth is a sphere of uniform mass density, what is the percentage decrease in the weight of body when taken to the end of tunnel 32 km below the surface of the earth? And information given is radius of earth is 6400 किलोमीटर. तो अब इस क्वेश्चन में क्या गिवन है कि कोई अर्थ में हमने टनल बनाई है और उस टनल की जो लेंथ या डेप्थ हम बोल सकते हैं वो डेप्थ है 32 किलोमीटर. देन एट दैट एंड ऑफ दिस टनल व्हाट विल बी द इफेक्ट ऑन वेट ऑफ द ऑब्जेक्ट. तो यहाँ पे पहुँच के वेट पे क्या इफेक्ट पड़ेगा, कितना परसेंटेज वेट डिक्रीज हो जाएगा. ओके, सो वी नो दैट द फॉर्मूला फॉर वेट इक्वल्स टू m into g. Mass will not change for the object, but g will change. So initially g at the surface of the earth and change in g, so final g will be at this point. So at this point, how can we take out that how much g will change? So at this point, only this part of the earth will be responsible to make or to attract the object. So only this part of earth will produce gravitational acceleration force on this object. Okay, so we have the formula for g also, that's g equals to capital G capital M upon r square. That is very common formula we have learned in class 9th also, where m is the mass of the earth, r is the radius of the earth or planet. We can change this formula in different terms because it is given here that earth is of uniform mass density. So we consider the mass density of earth as rho. Then rho equals to m upon v. So m will be equals to rho into v. So we can put it here. G, instead of m we can put density multiply volume. Volume is 4 upon 3 pi r cube, because it is mentioned here the earth is a sphere. Okay, whole upon r square. Cancel it out, then we have the formula for g, capital G, okay, 4 upon 3 capital G pi rho into r. Okay, and at this point the radius is somehow different from the complete capital R. We are taking it as small r, and at this point we are taking g as gravitational acceleration as g dash. Then g dash will be equals to 4 upon 3 pi capital G rho into small r. So small g dash at this point and g dash g only at this point. So what we need to calculate percentage decrease in weight. What is the formula for weight? M into g. So percentage decrease will be change in weight upon actual weight multiply 100. So change in weight will be m into g minus m into g dash upon m into g multiply 100. Now m will be common from numerator and denominator, so it will be cancel out. Then we will have g minus g dash upon g multiply 100. If we separately divide by capital G here, then 1 minus g dash upon g multiply 100. Okay, now we are calculating only g dash upon g, g dash and g. So g dash upon g, it will be 4 upon 3 pi g rho r upon 4 upon 3 pi capital G rho capital R. All other things will be cancelled out, only we will having, all these things are constant, only we will having R upon R. So instead of G dash upon G, we can put small r upon capital R multiply 100, and by taking LCM it will be capital R, here it is capital R minus small r whole upon R multiply 100. What is meaning of capital R minus small r? Capital R meaning full radius of the earth from this point to this, and small r is from this to this only. So the gap it will be this much. So this much value is already given in the question, that is 32 kilometer. So we'll put here the values, that r is 6400 and the r minus r dash, r कहाँ से कहाँ तक है, r पूरी रेडियस है और स्मॉल r यहाँ तक की वैल्यू है. तो जो बचा हुआ हिस्सा है वो हमारा ये टनल की लेंथ है, और टनल की लेंथ हमें दी हुई है 32 किलोमीटर. सो वी विल पुट हेयर r minus r dash as 32 upon 6400 multiply 100, 0 से 0, 0 से 0, 32 2 times, so 1 upon 2 percentage or 0.5%. So second is the correct answer for this, 0.5%. 0.5% will be the decrease in weight of the object when the object is reached at this position. Okay, thank you.